Okay, now that you understand about these ion channels that sit on the plasma membrane, you understand how ions move across the membrane, you understand the concepts of depolarization and hyperpolarization, we can talk about the action potential, or casually called the nerve impulse, but this action potential that moves down an axon and ultimately creates neurotransmitters to be released at the axon terminals. So the way I explain it, there are 4 phases, okay? And they're listed right here. The first is the threshold phase. So there's our -70 resting membrane potential. Now, something is stimulating the dendrites of a cell to provoke it to fire an action potential. That stimulation, that excitation, that excitatory stimulus is undoubtedly a neurotransmitter that is binding to chemical-gated sodium channels. The neurotransmitter is the chemical. This is happening out on the dendrites. So it's binding chemical-gated sodium channels. It's opening up those channels. We know sodium will move in based on the electrochemical gradient, and that will depolarize the cell, just like that. So phase 1 threshold is due to chemical-gated sodium channels. It's due to sodium, and it depolarizes. Okay? Then we get to this next level. It's called -55 millivolts, and it turns out that this number is very important because it's the thing that stimulates voltage-gated channels. So as soon as we hit -55, a different set of sodium channels open. These are voltage-gated sodium channels. Same thing happens though. Sodium comes rushing in, depolarizes the cell, but it does it in a big way. Rapid depolarization. Okay? And then at some point they spontaneously shut off up here. And what happens next is repolarization. Repolarization, we're coming back down to where we were. So the only way we can do that is to dump some of these positives out. And one way we do that is up here, we open up voltage-gated potassium channels. So this voltage up here is somewhere between +30. The potassium channels open. Potassium leaves the cell now, according to the electrical chemical gradient, causing this repolarization back down to the resting membrane potential. Actually overshoots it a bit. And now to get this cell ready to fire the next action potential, it's kind of messed up with its ions now because it's got a bunch of sodium inside the cell and it's got a bunch of potassium outside of the cell. In order for it to get ready to fire again, and our nervous system has to be ready to fire rapidly, we have to get that sodium back out and the potassium back in. And we do that in the 4th phase called after hyperpolarization. And this uses both sodium and potassium ions, and it uses what are called sodium-potassium pumps, which I'll explain in the next slide. But please pay very close attention to the phases in this slide, each ion that's responsible for each phase, and each ion channel that's responsible for each phase.